Hello and welcome to This Explainer. I am absolutely thrilled to have you here today. Whether you're a seasoned educator or a brand new teacher getting geared up for the year ahead, we're going to unpack the Grade 6 coordinate plane unit together. Our goal today? Well, it's to transform all this source material into a clear, actionable roadmap for your classroom. We'll be taking those core standards, specifically 6.NS6, 6.NS8, and 6.G3, and breaking them down so you know exactly how to guide your students straight to mastery. Let's get into it. Here is our roadmap for today. We'll hit 5 key stops: mapping the unit goals, expanding to 4 quadrants, distances and polygon creation, key academic vocabulary, and finally, anticipating common student misconceptions.
All right, let's kick things off with Section 1, Mapping the Unit Goals.
Now, as any great teacher knows, to effectively guide your students forward, you've got to ground yourself in what they already know, right? Think back to 5th grade. Your students got very comfortable in just the first quadrant, mostly dealing with nice, friendly whole numbers and positive values. But in 6th grade, we're asking them to take a massive conceptual leap. We're tossing them into all 4 quadrants, introducing negative numbers, integers, and rational numbers into the mix. Honestly, it's a huge cognitive shift for them.
But here's the thing to remember. This unit doesn't just exist in a vacuum. It builds directly upon that solid groundwork laid in 5th grade with standards 5G.1 and 5G.2. We are absolutely not throwing out what they know. We're just taking their current worldview of numbers and space and expanding it outwards and downwards.
And this is exactly how we do it. We guide them through a beautifully sequenced step-by-step progression. We start simple by plotting whole number coordinates. Then we explore reflections. From there, we ramp up the rigor by plotting rational numbers, so your fractions and your decimals. Once they've got a handle on that, we introduce finding distances between points, and ultimately, the grand finale is having them create full geometric figures right there on the plane. It's just a fantastic staircase of skills.
Moving right along, let's dive into Section 2, expanding to 4 quadrants. Okay, this is where the magic really starts to happen for 6th graders. By simply extending that x-axis over to the left and dropping the y-axis down to include negative values, we suddenly bust wide open quadrants 2, 3, and 4. The coordinate plane goes from being this little cozy corner of their paper to a vast 4-part grid. And this directly targets standard 6.NS.6, which is all about understanding rational numbers as points on this expanded plane.
So what does this actually look like in practice? The crucial point is teaching students the new rules of the road for this territory. They need to learn that opposite signs indicate locations on opposite sides of the number line. But even more importantly, they need to recognize how the specific signs of an ordered pair, positive negative or negative negative, literally dictate exactly which of the 4 quadrants a point is going to live in.
And tucked right inside this standard, we introduce the truly fascinating concept of reflections. When 2 ordered pairs differ only by their signs, like, say, a positive 3, positive 4 versus a positive 3, negative 4, those points beautifully mirror each other across an axis. It's an incredibly visual way for students to grasp the concept of absolute value and distance from 0, usually without even realizing they're doing it yet.
Let's shift gears to Section 3, Distances and Polygon Creation.
So, now that they know how to plot points literally everywhere, what do we actually do with them? Well, we step up the rigor. We transition from just plotting single, isolated points to actually analyzing the relationships between them. Specifically, we're hitting standard 6NS.8 here. We want students to find the exact distance between 2 distinct points that share either an x-coordinate or a y-coordinate.
And let me tell you, this is a thrilling, multi-layered skill for them. First off, students have to pay very close attention to the graph's intervals and scale, which honestly is a super frequent stumbling block. Then, they use the concept of absolute value to calculate those distances. Once they can confidently find distances, they start connecting vertices to create polygons. Suddenly, they aren't just plotting random dots anymore, they're drawing rectangles and triangles and figuring out their exact side lengths.
I absolutely love this quote from the source material. Applying knowledge of geometric concepts, students will see how the coordinate plane can be useful to measure perimeter and area of figures. By applying these techniques, the whole coordinate plane transforms in the student's mind. It evolves from a boring mathematical grid into a highly practical, real-world tool for measuring the perimeter and area of actual spaces. It's a total game changer.
Okay, Section 4, Key Academic Vocabulary.
To successfully navigate this huge new map, you and your students are going to need the exact right toolkit.
And in math, that means absolute mastery over the academic vocabulary. Let's rapidly run through these crucial terms, starting with absolute value. It is vital that students understand this simply means a number's physical distance away from zero on a number line, completely regardless of direction. Remember, distance is always positive, and that's a pretty big conceptual hurdle for some kids. Next up is the coordinate plane itself. Informally, it's our map, but formally, it's defined by the intersection of the perpendicular x-axis, which runs horizontally, and the y-axis, which runs vertically.
Then we have integers. Make no mistake, integers are the absolute backbone of this entire unit. You have to ensure students know this comprises the whole set of whole numbers and their corresponding opposites, the negatives, right there on the number line. Now, when we're dealing with those reflections across the axes that we discussed a minute ago, we introduce the term image. The image is simply the new shape or figure after a transformation has occurred. Having this word helps them cleanly differentiate between their original starting point and their final result. And of course, there is the origin. This is that exact 0, 0 point in the very middle. It's where the x and y axes intersect. And it is the universal anchor point where our entire mapping journey always begins. Finally, the ordered pair. This is the fundamental combination of an x-coordinate and a y-coordinate, wrapped up nicely in parentheses. It's basically the exact GPS coordinate that gives us our precise, unique location on the map. And that brings us to our final stop, Section 5, Anticipating Common Student Misconceptions. The beautiful thing about being an educator is that we don't have to just wait around for our students to fail. We can proactively predict and navigate the common hurdles they're practically guaranteed to face thanks to years of data. Anticipating these struggles means we can frame them differently in our lesson plans. We don't view them as failures, we view them as predictable, highly manageable milestones on a learning journey. If we know where the potholes are, we can just expertly steer right around them.
So according to the curriculum guide, you've got to keep a really sharp eye out for these 4 specific issues. Number 1, swapping the x and y coordinates. We see it all the time. Remind them they have to walk down the hallway before they take the elevator up. Number 2, missing the graph scale. They might assume every single grid line represents 1 unit, even when it's actually a half or a tenth. Number 3, struggling to plot rational numbers in those tricky spaces between the grid lines. And number 4, missing that super elegant link between reflected points and their opposite signs. Pre-teach these pitfalls. We've covered the progression of skills, the specific standards, the vocabulary, and the common pitfalls. You are now fully equipped with a crystal clear roadmap for this grade 6 unit. So I'll leave you with this final thought. With this mathematical map now fully expanded in front of you, how will you empower your students to conquer the coordinate plane tomorrow? Thank you so much for joining me for this explainer, and happy teaching.